Hello, my name is Carol. Welcome to the GoodCode channel. Today, let's go on another journey through the binary tree and see if we can come up with the sum of all combinations of numbers created by traveling from the root to the leaves. Okay, and this joyful exercise is brought to us by the Amazon. Okay, so first of all, as you can see, the tree is exactly the same as we had last week, and what we will try to do today. We will try to sum all the combinations of the numbers. And how are we going to come up with the combinations? That's pretty easy. We will travel from the root to the leaf and see what kind of numbers pop up. So, in our case, we will have three numbers. First one will be 124, 1357, 1368. Okay, so we will try to come up with the sum of these three numbers. Okay, so let's start coding. So before we start coding, let me ask you again, please try to solve this question all by your own, and just after that come and check if our solutions are the same. Okay, because this is how you learn, by doing it yourself. Okay, so as always, code will be provided at the video description. It will be placed on the GitHub. And as far as it goes for the tree structure, the way we create it, it's exactly the same as it was on the previous video. So I won't be describing it in this video. You can go to the previous one. The link will be provided. Okay, so what interests us is this function, the function that actually comes up with the sum. Okay, and over here we see that number we are looking for is 2849. So I will place breakpoint over here, and all what we are doing is passing the tree to find root to leaf function. Okay, and we will discuss only the function. As I said, the talk about the tree is in the previous video. Okay, so I will clear my console. I will press F5, and then we will start talking about the code elements. Okay, so yeah, we have all what we need right now. I will close the variables, the call stack. All I need is watch, and let's see what we have. Okay, we have a node. Node points to the beginning of the tree, to the root. So over here, we also will have a result that will be used throughout the function, and basically that's quite it. We also have the sum value. Okay, another value that will be passed around. So not too much of it. It's pretty concise, to be honest. And let's go. So as in all the cases of the sum functions, we will start with 0, because 0 is neutral value when it comes to sum. So let's go. Okay, result is 0. We are at the base. We are in the root node. Okay, root 3 ID 1. Cool. And let's go to count sum. Okay, so we'll start summing from our root, and we will start with the node ID of 1. And that might raise some questions. Why passing ID over here when it's over here? Why can we simply extend the element that we are passed, so the tree? And that's the thing. We shouldn't be changing without noticing our user. We shouldn't be changing elements passed to the function without noticing our user. And as for the tree, it is reference type, so we'll be better off by creating new value, passing it, and the tree shouldn't be changed after our function works on it. Okay, so keep that in mind. So let's start our journey. Okay, we are at the count sum function. The sum value so far is 1. Okay, so what are we doing now? We are checking. Okay, I will add 2 more elements just to make it crystal clear. It will be node left, and it will be node right. Okay, they both here, and we see node left does exist. It's 2, okay, because we're 1, so the node left is node with the ID 2. So we will call count sum again. Now the node will be left 1, and the sum will be current sum, so 1 plus ID of the node, so 2. Okay, so F10, we are exactly at the same place now. Okay, we are exactly in the same place, but the values have changed. Now our main node is number 2, yeah, we're over here, and the current sum value is 12, okay, because it is 1, 2, cool. And again, does our current node has a left node? It does, it's 4, okay, so the recurrent function will be called. Okay, again, we are at the 4, so over here, yeah, some value is 124 because it was 1, 2, 4. Okay, so we'll continue. It moves through both ifs because both the left and the right are null, because the node with ID 4 has no child elements. So now we can do the adding. Okay, so if not true that left and not true that right, we will add. So the result, our 0, we will pass the sum value parsed to int. Okay, so boom and boom. There we are. The current sum is 124, and let the recurrent function do its magic. Now again, we are at the node number 2. We are checking if because we went back, yeah, we went to this child, this path was over, so the recurrent call goes back and it checks the right. Right doesn't exist, the 2 isn't the last node, so we will go back. Okay, we go back to number 1, as we can see, and then we will start traveling this path. Okay, we are at at the node number 3, so the right one. And again, we check node 3 exists, so we are calling our function. Okay, now the left node is the one with the 5. Okay, left 5. That's why we will call the function with left node as main, and so on and so on. Okay, and so we travel through our tree by checking the nodes and calling the function. With each call, we are going further and further down the tree, and the sum value changes. Now we see that we are at the node number 7, so the one over here, and the sum that we came up is 1357, so 1357. We have traveled down this path. Okay, so we will add it to our result. Okay, so it's 1481. Okay, and that's the way it goes. It travels the tree around and around, and when I hit F5, so let the function go, we will end up in our result. So the result is 2849. So the result of traveling all the 3 paths that are of interest to us. Cool. It was a little bit harder exercise than last week, at least for me, because our function has to travel to all the end leaves. But I think it was quite cool. If you have any questions, please feel free to reach me in the comments. It's the best way. And if you learn something, please leave a like. That really helps me a lot to know what kind of content to provide. And thank you for watching. Bye.